Namaste student. Today we are going to start a Namaste student. Today we are going to start a new chapter, that is the construction. And in our construction for class 9, we can see the first question, that to construct an angle of 60 degree at the initial point of a given ray. It's a very simple to draw this 60 degree. Already we have done this one in class 6. So let's see, let's recapitulate it. What we're going to do, we'll take on a line segment or a ray. From the initial point, we'll draw a semicircle by your own radius. Take your own radius and draw a semicircle. And then from this point, cut an arc. So this will be, if we'll join it, this will give you 60 degree. Now this much was there in class 6. Now we're going to justify it. How could you say that this angle is 60 degree? This question may be arise in your mind, that how could you say? So let's see, let's join this part also. We'll join it here. What you can see that this and this are equal. Like, that means give a name O, A, B. Then OA equals to OB equals to AB by construction. So if we take a triangle, in triangle OAB, you can see that OA, AB and OB are equal to one another. That means we can say that if all sides are equal in a triangle, we can say that triangle OAB is an equilateral triangle. And we have already seen that in equilateral triangle, each angle equals to 60 degree. This implies angle O equals to angle A equals to angle B equals to 60 degree. And this is our target, that angle AOB equals to 60 degree. This is our justification for 60 degree. Now we'll proceed for 90 degree and then we'll proceed for 45 degree. Let's see here. Construct an angle of 60 degree at the initial point of a given ray and justify the construction. So now we're going to first construct a 90 degree. Already we know how to construct it. So do here, take an align segment, take a point and draw a semicircle. And then cut it here for 60 degree and then 120, cut and get here 90 degree. Join it. Center and this one. If we'll join, you will get 90 degree. Give a name. We'll take here name X and this is your Y, and here we need O. That means our target to prove angle XOY equals to 90 degree. This is our target. So how are we going to prove it? So for that, what we're going to do, we'll join this part, this one, O and this part, join it and join here. If we'll join, you can see that this is your equilateral triangle. Already we have proved it. So give a name A, B, and here also you join it. Join it like that. If we join, you can see here and give a name C, D. So to prove X, O, Y or A, O, D 90 degree, your target, if you show this much 90 degree, we can find it. So how are we going to do? We already know that angle AOB is 60 degree, as AOB is an equilateral triangle and we need to show that this part is your half, means 30 degree we need to show. Okay, how will we do? So for that we'll join this part also. So if you join it, you can see that AOB, BOC are two equilateral triangle. That means this is your 60 degree and this is also 60 degree. And our target to show that this triangle COD and BOD are congruent triangle. If we show, then we can say that this much, that means COD equals to BOD. And then we can say that half means 60 degree, half of 60 degree is 30 degree, and we will get here 30 plus 60. So let's prove it here. So by construction we have what we have proof. We'll start here. So we'll use your pen here. In triangle AOB, and you can see that what, and triangle BOC, what we can see that angle, not angle, OA equals to OB equals to AB, and OB equals to OC equals to BC by construction. Therefore we can say that triangle AOB and triangle BOC are equilateral triangle. If it is equilateral triangle, this implies angle AOB equals to angle BOC equals to 60 degree, as each angle of equilateral triangle has 60 degree. Now our target to show that triangle COD and BOD are congruent triangle. Now we'll go for congruency. In triangle COD and triangle BOD, what you can see that CO, see here, CO equals to BO. Why? Because you can see here by construction you have taken this one without changing here. Have you seen? By construction without change we got these two are equal. Not only this also we have got equal. But this is not our target. Our target is right now OB equals to OC. So OB equals to OC, or you can say that CO equals to BO by construction. Next, what you can see that CD, this is also by construction. You can see here this much CD equals to your BD. So CD equals to BD. This is also by construction. And the third one, that is OD equals to OD equals to OD, matlab for both it is common. Therefore we can say that triangle COD congruent to triangle BOD by SSS criteria. If these two triangles are equal, then their corresponding paths must be equal. That means COD equals to BOD. Therefore we can say that angle COD equals to angle BOD by CP corresponding part of congruent triangle. Now if these two are equal, and already we have seen that, but we have seen that BOC we have seen that 60 degree, and it's showing that BOD and COD are equal. That means 60 and these are equal to each other, but the half of 60 degree. This implies angle BOD and COD. So our target is only BOD. We will take BOD because this side we are going to prove. Or you can say that COD equals to BOD equals to half of angle BOC. This means half of angle 60 degree. This means 30 degree. Therefore we can say that angle XOY equals to what? Angle AOB plus BOD. So this is our 60 degree and this is our 30 degree. equals to 90 degree. This is our justification for 90 degree. Okay. Now we'll proceed for 45 degree. So for 45 degree, first we're going to construct a 45 degree using 90 degree, and then bisector of 90 degree, we can say that 45 degree. So here we have, we'll take our initial point. Here we are taking a ray, initial point, and from the initial point take a semicircle. Here we have semicircle without changing. See here, we are not changing here. So without changing, by construction, we are taking an arc here this side. Put here, take an arc. Again here for 90 degree. So this is our 90 degree. And we need a point for 90 degree on the semicircle here without changing. So this is our target. Now half of 90 degree. Half of 90 degree equals to what? 45 degree. So here we are getting, so this is our 45 degree. So join it here. So you can see that. If you check, you can check here, no problem. If you check here, you can see here, this is our 45 degree. Okay. Now we need to prove it that it is 45 degree or not. So for this one, already we have proved 90 degree. 90 degree we have already taken. So directly we will write here x, o, and the y we need here. Okay. So join it also by dotted line, using dotted line, as this is not our target. So we keep here dotted line. So x, o, y. So by construction we'll write this one, because right now we're going to justify for your 45, so we're not going to show for 90 degree, just directly we'll write here by construction angle XOY equals to 90 degree. Okay. Now after that, join it, join the part. Already you have joined here, so take this part because you have taken the arc here. So this one and this one you join here, line segment, and from this side you join it here. Okay. Okay. Now what we can see that this and this, have you seen, all are equal to one another, and already we got this is 90 degree. So this is a square. Okay. No, we can say by square also, or sometime we can extend it and then we can find for 90 degree. Okay, we can do like this also. See, we are extending and we can get it, and you can see that it will touch this line segment only. Okay, this intersecting point will touch this line segment. So it's not hard and fast rule that you need to take the same after getting 90 degree. Angle bisector you can find without keeping the same arc or line segment. Okay. Right now what we're going to see, will show that this equals to 45 degree or this equals to 45 degree. Our target is this equals to 45 degree. You give a name here AO B C, that means angle AOC equals to 45 degree is our target. So how are you going to, just you show that these two triangles are congruent. Once you show that these two triangles are congruent, then we can say that this equals to this, and that means half of 90 degree equals to what? 45 degree. So if you see in triangle AOC and triangle BOC, what you can see that AO, or you can say that yes, AO equals to what? BO by construction, or you can say that radius of semicircle. Okay. Now what? This one, this OC is common to both. OC equals to OC, common. And the third one, BC equals to AC. See, without changing we have taken. So either we will take this one like that, or you can go for this one also. So whatever. So right now we have taken this one. So we'll write here BC equals to your AC equals to BC by construction. Now we can say what we can say, that therefore triangle AOC congruent to triangle BOC by which rule? SSS, congruency rule. So if these two triangles are congruent, that means we can say that angle AOC equals to angle BOC by CPCT, है ना, corresponding part of congruent triangle. Therefore, if these two are equal, that means this imply angle AOC equals to angle BOC equals to half of angle XOY, that means AOB, half of angle XOY. This means half of angle 90 degree, this means 45 degree. This is our justification for 45 degree. I hope you people have understood. Thank you.